Our Tennessee state standard for today to use numbers expressed in the form of a single digit times an integer power of 10 to estimate very large or very small quantities and to express how many times as much one is than the other. For example, estimate the population of the United States as 3 times 10 to the 8th and the population of the world as 7 times 10 to the 9th. Your lesson objectives that you need to pause the video and write down. I can, or I am learning to, convert numbers from scientific notation to standard form and convert numbers from standard form to scientific notation. All right, 4.5 times 10, or 4.5 times 10 to the first is equal to 45. And you can read these on down through there. But what I want you to do is think about the question, what relationship do you see between the factor 4.5 and the answer? And think about what role does the exponent play? And tomorrow we'll have a chance to talk about those within our groups. So scientific notation is just a compact way of writing numbers with absolute values that are very large or very small. With scientific notation, one factor is greater than or equal to 1, but less than 10. You will only have one digit before the decimal, but you must have one digit. The power of 10 is written in exponential form, times 10, and then this is to the negative fourth power. Multiplying by positive power of 10 moves the decimal place which way? Well, since the number is getting bigger, it moves the decimal place to the right. And multiplying by negative power of 10 moves the decimal point left, which gives a smaller number. So multiplying by negative power, think about negative exponents and how we actually got rid of the negative sign by using the reciprocal. So multiplying by negative power is the same as dividing by that positive power. All right, so to write a number in standard form, our exponent tells us the direction to move the variable and how many places, or not the variable, sorry, the direction to move the decimal and how many places to move the decimal. So since this is a 4, a positive 4, we're going to move that decimal place 4 places to the right. So 1, 2, 3, 4. And we fill in empty spaces with zeros. So that would give us 53,400. I'm going to write this over here so I can, or I'll write it right here so I can move my decimal. So since this is a negative exponent, that means I'm going to move my decimal left 3 places. So 1, 2, 3. Fill in with zeros. All right, so here are some more examples. The 5 tells me to move my decimal 5 places, and since it's positive, I'm going to move it to the right. 1, 2, 3, 4, 5. And this is how I expect you to show your work. Just rewrite it so you can move the decimal, and then rewrite it in standard form. So 6.1, I'm going to move my decimal left 2 spaces, 1, 2. Which would give us 61 thousandths. So I move my decimal 2 places to the right, 1, 2. which would give me 371 4/10. So the exponent tells you which way to move the decimal, and it also tells you how many places to move the decimal. All right, if we want to write numbers in scientific notation, step 1, we rewrite the number with a decimal point after the first natural number. Step 2 is always times 10. That's the easy step. And then step 3, we're going to find the exponent by counting the numbers between the original decimal and the new decimal. Then, to determine if our exponent is positive or negative, we look at the original number. If the original number is greater than 1, the exponent is positive. If the original number is less than 1, the exponent is negative. All right, so step 1. We rewrite the number with the decimal after the first natural number. So 3 is our first natural number. And because we have this decimal, we do not have to put the ending zeros. Unless there's another significant non-zero digit, we do not have to put the ending zeros. Step 2 is times 10. So we take that number, we multiply times 10. Step 3, we want to see how far, we want to get our exponent, so we have to see how far we moved the decimal. The decimal's sitting right here, and we moved it to here. So we keep our 3.725 times 10, and we moved that decimal how many digits are between? We have 1, 2, 3, 4, 5, 6. And our original number, 3,725,000, is greater than 1. Therefore, our exponent is positive. All right. With the second example, we rewrite the number with a decimal after the first natural number. So 3.16. Step 2 is always times 10. So now we end up with our decimal right there. How many places did we move the decimal? How many numbers are between these two decimals? Well, we have 1, 2, 3, 4. Now, to determine if it's positive or negative, our original number is less than 1 because it's 0.0. So that means our exponent is negative. So 3.16 times 10 to the negative 4. More examples. Step 1, write the number with a decimal after the first natural number. Step 2, times 10. The decimal was here. We moved it here. How many numbers are between that? 1, 2, 3, 4, 5, 6, 7. And our original number was greater than 1, so our exponent stays positive. Step 1, rewrite the number with the decimal after the first natural number, so that's where it's going to be, 8.76. Step 2, easy step, times 10. Step 3, count the numbers between the original decimal and the new decimal. It's 3, and our original number was less than 1, so that makes our exponent negative. And the last example, step 1, rewrite the number with the decimal after the first natural number. Step 2, times 10. Step 3, find our exponent. We have 1 digit between the decimals, and since the original was less than 1, our exponent is negative. And that is the end of today's lesson.